Welcome to Quinn Global. This is Carl Fowler, and we have with us today Paul Richardson from CDUK.
CDUK, yeah.
Welcome.
Thank you.
We're going to be demonstrating the use of L42, which is the new adhesive which we've been working with you guys on.
Yes, that's right.
To bond all thicknesses of the Corian materials to all substrates. Well, Paul, what we're going to do to start with, we're going to connect the equipment to the canister to actually show the ease of how putting this system together is going to be.
Yep.
So we've got the knife. Now, in this box here is what we call the kickoff kit. The kickoff kit is your gun, your hose, and a roller. Now I know that they're not going to necessarily be using the roller, but there may be areas where they will want it, and it's a good handy addition to the box. Also in there's a football book. Let's open it up. So here we go. Well, number one, they're going to get a nice football. So you can do whatever you want with that.
Very good.
Okay, good. There's the roller. We have the hose, and then we finally have the gun. So we'll move the box over there. Move over to the hose. Bring this up. And then here we have the gun. So what we're going to take that out. There is instructions in the box as well, but for the purpose of this video we'll just work with what we actually need to work with. So the gun itself is all there is to the spraying of this total system. We're going to be connected to the hose to here. The liquid goes into nowhere over the other part of the gun, and it simply comes out in the nozzle. This is your adjustment screw for fluid rates, and that will adjust the spray pan, and we'll go over that shortly. So Paul, what we're going to be doing now is we're going to connect the hose to the gun. It is a very simple action. We're going to take the large end of the hose, and we're going to put it on by hand onto the thread on the gun. And what we're looking to do is make sure that the movement between the nut and the hose is tight. It will need further action with a wrench or a spanner. So we're going to put that onto the bench and just tighten that up. We're not looking to over tighten it. We're looking to tighten it so that there is no movement and it's rigid in that position. So we have the gun connected to the hose successfully. The next point is to connect this end to the hose, to the canister. So we'll just bring that over here. So by just simply attaching it into the end, making sure it's aligned, and just connect up, take the small wrench and connect it to tight. Well, again, we're not looking for this to be crazy tight. We're looking for it to actually be so it's rigid. So we're up there, we're ready to go. So the product that we have today, Paul, is the TensorGrip L42.
Yes.
This product we have obviously been working with you on.
We needed a glue that was totally flexible for Corian, and it has to be at least as flexible as silicon. Corian is a thermoplastic. It's constantly on the move with temperature change, so it needs to be a fully flexible bond throughout its lifetime.
So with that being said, we obviously came up with the development of L42.
Yes.
For that fundamental point is that the flexibility of this material is critical to obviously allow for the thermal expansion and contraction. And one of the things that's been shown in all the test proceedings is the fact that this adhesive, although it be a very thin bond line, maintains that incredible amount of flexibility throughout its lifetime. That can be seen in the way that the pull test shear values actually come out, and obviously the material comes back together to its original state, and that was obviously a #1 criteria for this particular material, and I think we've met that. Great.
The speed of the application, especially on larger projects, we're clad in big counters and things like that. Traditionally we'd use silicon and hot melt. This glue is incredibly fast. We can have quite a small fan, so if we're doing delicate bits that's fine, but then we can spread it up to maybe about 400 wide, so we can get fast panel coverage.
Absolutely. No, that's great. Well, obviously we can actually demonstrate that now for you, Paul, as well, so that anybody that's watching this video can actually see the flexibility that they have with the user friendliness of the system in its own right. So we're going to pressurize the canister up.
Okay.
So everything's connected here. We're happy with this.
Tight, yeah.
This is all tight. Making sure that the nozzle in itself, that the fan is upright in the gun in itself. Okay. So that's nice and tight. We'll shut the gun off because we'll always start at 0.
Yeah.
It's not that would actually spray immediately, but it's always good to actually start off at a lock point.
Yeah.
Okay, we're connected up here, and now we're just going to gently open the valve. Okay, and you can hear the pressure coming through,
yeah.
and that is now the gun and hose system now fully pressurized. Just wind the valve completely out, and now we're ready to go. Okay, so there is no air in this system, Paul. Okay, so the adhesive comes up the hose and out the gun. It is purely the volume of adhesive adjusted by this nail screw here.
Okay.
The further back the trigger comes, the wider the spray pattern. It's very, very simple. So here we go. So we're going to start at 0, and there may not be much coming through. Okay, so we basically just keep widening that out, and then you'll get the adhesive coming through.
Yeah.
Once the adhesive is coming through, that's to the nozzle. We now would lock that back and actually start at 0 to actually get the fan width. So that's obviously very, very narrow. You can get it, and then you would widen it out. The further, I just literally just quarter turns.
Yep.
I can get it out. So the maximum per fan width is about 6 inches.
Yeah.
Okay. And what we're looking for is a fine, consistent spray pattern. So it's extremely adjustable, and obviously it works in every position. So if I just put it at an optimum point, I can spray around the edge without getting any overspray.
Yep.
Okay. So that's how simple the system is.